Somewhere in Ukraine, a sunflower field grows through cracked, contaminated soil. Across drought-stricken regions of Africa, a tree that looks half dead keeps producing leaves packed with more nutrition than most vegetables you buy at a store. And deep inside the ruins of Chernobyl, something is thriving in the dark, feeding on radiation itself, as global tensions rise and supply chains begin to fracture. Scientists and survival researchers have turned their attention to a quiet category of life that has existed for thousands of years without needing perfect conditions to survive. These are not ordinary crops. These are living systems built for extremes. Before we get through this list, we'll show you a plant that cleans poisoned land, a tree that feeds people with almost nothing, and a fungus found living inside an active nuclear reactor. One of these has been called the food of warriors for over 2,000 years. Stay with us, because the last one might genuinely surprise you. Plant number 1 is amaranth. Most modern crops are demanding. They want deep, nutrient-rich soil, consistent rainfall, and careful attention. Amaranth asks for almost none of that. It grows in poor, thin soil with low nutrients. It handles intense heat. It matures faster than many staple crops. And in regions where standard agriculture struggles, amaranth keeps producing. But here is what makes it genuinely remarkable. Each small amaranth seed contains around 14 to 17% protein. To put that in perspective, white rice sits at roughly 7%. Amaranth also carries iron, calcium, magnesium, and fiber in one plant that grows where most others fail. The Aztec civilization understood this. For hundreds of years, amaranth was a central food source, used in ceremonies and carried by warriors on long campaigns. Spanish colonizers, recognizing how dependent the Aztec people were on this grain, actually banned its cultivation as a way to weaken the population. A food source so powerful it was considered a political threat. Today, amaranth is being studied again, not for conquest, but as a potential answer to food scarcity in a warming world. When the soil is poor and the rain doesn't come, amaranth grows anyway. Plant number 2 is Moringa. It grows in scorching heat, with low water, in soil most farmers would abandon. It sprouts back quickly, even after being cut down. Moringa is sometimes called a survival tree, and once you understand what it contains, that description starts to feel accurate. The leaves of the moringa tree carry significant amounts of vitamin C, calcium, iron, and potassium. Some comparisons are striking. Gram for gram, moringa leaves reportedly contain more calcium than milk, more iron than spinach, and more potassium than bananas. But what separates moringa from most survival foods is that nearly every part of the tree serves a purpose. The leaves can be eaten fresh or dried into powder. The seed pods are edible. The seeds themselves can be used to purify water by causing sediment to clump and settle. In communities with limited access to clean water, that is not a minor detail. In parts of sub-Saharan Africa, Southeast Asia, and South Asia, moringa has supported communities during food shortages for generations. Organizations working in famine-affected regions have returned to it repeatedly as a reliable, low-maintenance nutritional source. Before we continue, think about this. One of the plants still ahead on this list doesn't just survive in a contaminated environment. It may actually feed off of that contamination. Plant number 3 is cassava. Here is something most people in wealthy nations never think about. What happens to food security when the power grid is unstable, transport routes are disrupted, or farmland dries up for a season? For over 800 million people worldwide, the answer to that question involves cassava. Cassava is a root crop. It grows in thin, dry soil with minimal rainfall. But what makes it different from almost any other food source is this. Once the roots mature underground, they do not need to be harvested immediately. They sit in the earth, holding their energy, waiting for months. In some conditions, longer. This means cassava functions as a living food reserve. When conditions are poor and harvests of other crops fail, the roots remain safely in the ground until they are needed. The calorie content is high, making it one of the most efficient crops for feeding large populations under difficult conditions. It is the third largest source of carbohydrates in the tropics. In parts of West Africa, Central Africa, and Southeast Asia, it is simply a daily staple. There is one important caveat. Raw cassava contains naturally occurring compounds that can release a harmful substance if the root is not processed correctly. It must be peeled, soaked, cooked, or fermented properly before consumption. This is not new information. Communities that have eaten cassava for centuries have long understood how to prepare it safely. Plant number 4 is the sunflower. You probably recognize it. You may have seen it on a bag of seeds or a bottle of cooking oil. But there is a version of its story most people never hear. In 1996, scientists planted sunflowers in a pond near the Chernobyl nuclear power plant. The reactor had exploded a decade earlier, leaving the surrounding area contaminated with radioactive elements. The sunflowers did something unexpected. Their roots absorbed radioactive cesium and strontium from the water, pulling those toxins up into the plant itself. This process is called phytoremediation. Certain plants are able to draw heavy metals and toxins up from the soil or water through their root systems. After the Fukushima nuclear disaster in Japan in 2011, sunflowers were again planted in contaminated areas as part of cleanup efforts. The sunflower is not consuming the contamination in any useful biological sense. It is concentrating it. The plants must then be carefully harvested and disposed of. But the principle, using a living organism to extract damage from the land, is a remarkable one. Beyond environmental recovery, sunflowers grow across a wide range of climates, produce widely consumed edible seeds, and generate oil used globally. They represent something worth noticing. A familiar, beautiful plant with an extraordinary and largely unknown second role. Plant number 5 is not technically a plant at all. It is a fungus. But it earns its place on this list because it does something no other organism on this list does. It lives inside. Chernobyl. In 1999, researchers investigating the interior of the Chernobyl reactor discovered something alive on the walls. Certain species of dark, melanin-rich fungi had colonized the most radioactive zones of the building. They were not just surviving. Some research has suggested they may actually use radiation as a source of energy. Similar to how plants use sunlight for photosynthesis, the fungi contain high concentrations of melanin, the same pigment found in human skin. Scientists believe this melanin may play a role in interacting with radiation in a way that supports the organism's survival and possibly its growth. Studies have looked at whether fungi exposed to high radiation environments show increased growth compared to those in normal conditions. If confirmed, this would represent a genuinely unusual biological mechanism. Life finding a way to metabolize something that kills nearly everything else. These are called extremophiles, organisms that thrive in conditions considered uninhabitable. And while fungi from Chernobyl are not something you will eat for breakfast, they represent a scientific frontier that researchers believe may have implications for medicine, space exploration, and our understanding of life itself. The question is no longer whether life can survive extreme conditions. We have seen that it can. The question is what we choose to learn from it. From an ancient warrior grain to a fungus inside a nuclear ruin, life has developed ways to persist in conditions we would consider impossible. Amaranth fed civilizations in extreme climates and survived an attempt to erase it. Moringa quietly sustains communities across 3 continents with almost no agricultural input. Cassava stores food underground like a living reserve, waiting for when it is needed most. Sunflowers pull contamination out of damaged land with nothing but their root systems. And somewhere in the wreckage of Chernobyl, something dark and patient keeps growing on the walls as the world faces rising tensions. Climate stress and shifting food systems. These organisms represent more than interesting biology. They are a reminder that resilience does not always look dramatic. Sometimes it just keeps growing when everything else stops. If this gave you a different way of thinking about the natural world, consider subscribing. New documentaries go up regularly, and the next one covers something just as surprising. A quick note before you go. This video is for educational purposes only. Nothing here is medical advice, and nothing should replace guidance from a qualified professional. Statements about nutritional content or biological mechanisms reflect available research and are not intended as health claims or treatment recommendations. If foraging or consuming wild plants is something you are considering, do not attempt to identify or consume anything without expert verification. Misidentification can be dangerous. Sources are listed in the description below.